Okay, welcome to this video. We're going to be having a look at 5 difficult topics that can appear on a calculator paper. So in this video we're going to have a look at iterative processes, we're going to look at bounds with compound measures, we're going to look at quadratic simultaneous equations, 3D trigonometry that may include the sine or cosine rule, and we're also going to look at histograms and working out an average from a histogram. Now, as with all these videos, I am only going to go through one version of each question, so I will link in the description any further videos that you can use to revise for any of these topics. So before we get started, let's just have a look at how you can find them. So when you're on one of these videos, if you click into the description, you'll see that I've got everything listed within there. I've got hard questions to try, I've got checklists and practice papers that you can download, and other questions and other videos within this series. Now if you scroll down to the bottom of the description, you'll see down there it says topics featured in this video. So in there I'll put all the links with difficult questions and topic videos related to this topic right there for you to access. So just click onto one of those and it will take you on to more practice questions and different versions of this topic. So with that being said, let's get started. Okay, so looking at our first question. Now when it comes to iterative processes, there are two different types of questions. We've got this question here, which is a purely algebraic style of question, and then you also have a sort of in-context question as well. So I'll link in the description more of the in-context questions, but for this one we're going to have a look at this purely algebraic style of question. So for part A, it says show that the equation x cubed plus 4x is equal to 1 has a solution between 0 and 1. So what we're going to do is we're going to take those values 0 and 1 and we're going to substitute them into our equation. Now what we should find is that the answers are either side of 1, and that would mean that the solution has to be, or a solution has to be somewhere in between those two. So if we substitute them in, let's see what we get. So when we put 0 in, we get 0 cubed plus 4 lots of 0. And if we work that out, and you can type it in on your calculator, we get the answer 0. So that's below 1. If we substitute 1 in, we get 1 cubed plus 4 lots of 1. And if we work that out, that's 1 plus 4. And 1 plus 4 is equal to 5. Now that is above 1. So therefore, there must be a solution between 0 and 1 because 1 lies between 0 and 5. Okay, so we could just say that 1 lies between 0 and 5. There we go. We could say, therefore, there must be a solution. Okay, there must be a solution. There we go, solution between 0 and 5. Okay, now another method that you could use, okay, 0, let's just write that down, 0 and 5. What you could do is you could rearrange the formula. So you could put minus 1 onto the left-hand side. Now if you put minus 1 onto the left-hand side, then when you substitute 0 and 1 in, you will actually get a negative answer and you'll get a positive answer, which shows that there is a change of sign. So that's another method that you could use as well, which is a very good method. And that will show that there has to be a solution between, because where the graph is drawn, and if you were to imagine that we had an axis, the graph has to at some point have curved up or down, and the solution is normally between. Let's imagine we have a point here, which would be negative, and a point here, which would be positive. And that change of sign shows that it must cross through the x-axis. So there's two different methods that you can use. You can feel free to rearrange the equation and show a change of sign, or you could use this method as well. But I'll leave that up to you. On part B, it says show that this equation can be arranged to give x is equal to 1/4 take away x cubed over 4. So when approaching this, there are two ways of making x the subject. In this equation, we could either make the x with the x cubed the subject, or we could make the x next to the 4 the subject. So we want to have a look at which one they've made the subject. Now in the equation that we've been given, the x cubed is still there, but it's on the right hand side. So what they've done in the first step is remove that x cubed. So they've minused x cubed to the other side. So we would do that, we would write 4x is equal to 1 minus x cubed. Now there's only one more thing that you can do, and that is dividing by 4. Now normally if we were going to divide by 4, our next step would look like this. We would have x is equal to 1 minus x cubed, and we would divide it all by 4. And that's absolutely fine. This is just another way of writing the same thing. So when you have a fraction written like that, you can split it into two fractions when you have two pieces like that on the numerator. So instead of writing them both over 4 like that, we just separate them and we say, okay, well, x is equal to 1 over 4 and take away x cubed over 4. And there we go. And if that symbol on the top, let's imagine it said 1 plus x cubed over 4, then our answer would be 1 over 4 add x cubed over 4. So we're just keeping the same symbol that was already on the numerator, and we've shown that that can be rearranged. Now what I would probably also add, just to add an extra level of showing, obviously paying attention to that word, is I'd probably just write what I've done on each step. So I might have written minus x cubed on both sides there, and I might have also written divide by 4 here. We wouldn't have to write anything for this step here because all we've done is write it in a different way, but I'd probably write those steps along with my answer as well. Okay, so for part C, it says starting with x naught equals 0, use the iteration formula x with the n plus 1 is equal to 1 over 4 minus x cubed with the little n over 4, twice, to find an estimate for the solution. So when we are doing this, we have been given our starting number. Okay, now that doesn't look super clear there, but that would be an x with a subscript 0. Okay, so that's down the bottom, that's not a power of 0. So we're using the starting number 0. So when we do this with iteration, obviously I'm hoping you already know this topic to a certain extent, and if you don't, again, don't forget I've linked the full video in the description. But for this particular question here, all we're going to do is substitute 0 into the equation, and that will give us x1. So x1 will be equal to a quarter take away 0 cubed, because we're subbing the 0 in place of x, over 4. And we're just going to type that into our calculator. So I'm going to use my fraction button, 1 over 4, take away, press the fraction button again, 0 cubed over 4. And that just comes out as 1 quarter. So my first approximation to the solution of this equation is 1 quarter. Now what I'm going to do is I'm going to substitute the new answer in. So my new solution is now 1 over 4. And that's going to give me x2. So when I sub that in, I've got a quarter, and I'm going to take away a quarter cubed over 4. Now that's a little bit awkward to write on the paper, but what I'm going to do on my calculator, and this is where your calculator trick is involved, I am just going to go back into my calculation, I'm going to delete the 0, I'm going to press the answer button that just says ANS on the calculator. So on my calculator screen, it looks like this, answer cubed over 4. And all that has done is it's substituted the quarter in place of the answer. So you need to be very careful, because in order for this to work, the very last answer on your calculator has to have been that 1 quarter. If you've deleted it and typed in a different calculation, then it will no longer use the quarter. So you have to be very careful when you use the answer button. But now I can just press equals again, and it gives me my final answer. And my final answer comes out as 63 over 256. Now I can either write it as a fraction, or I could write it as the decimal version. Obviously the fraction here has a lot less numbers to write down, because the decimal is 0.24609,375. Now it doesn't ask us to round our answer, so if we are going to write it as a decimal, we should be writing down the whole decimal, but actually it's fine for us to leave our answer as the fraction. So I would have left my answer here as 63 over 256, and that would be my final answer, as it did only ask me to use the formula twice, and we've done that, and we've found x2. Okay, so there we go. There's our question looking at iteration. Okay, so for our next question, we're looking at bounds and we also have some average speed involved. So it says a high-speed train travels a distance of 487 kilometres in 3 hours. The distance is measured correct to the nearest kilometre and the time is measured to the nearest minute. By considering bounds, work out the average speed in kilometres per minute of the train to a suitable degree of accuracy, and you must give a reason for your answer. Now, this looks quite nice actually because it says in kilometres per minute. Had it have asked for kilometres per hour, we'd have just had some additional work to do here, making sure that our answers were all in hours. So we're going to have to write our error interval for the distance and also for the time. So for the distance, which is to the nearest kilometre, that means it could be half a kilometre below or above. So for our error interval for the 487, that would be 486.5 that it's going to be between and 487.5. And obviously just taking note that the left inequality there has that equal to as well symbol on there. Not that it really affects our bounds here, but we want to make sure we're writing our error intervals correctly. Now for the next one, that is the time in hours, and we're going to be using minutes. So let's just convert that into minutes. Not difficult to do, particularly when you have a calculator. 3 times 60 is 180. So we've got 180 minutes in 3 hours. So for this error interval here, which is to the nearest minute, that could be 1 minute, half a minute below or half a minute above. So that's going to be 179.5 and 180.5. There we go. And there are our error intervals. So if we had been asked to write that in kilometres per hour, we wouldn't have got very nice answers there. And you can obviously just test that out by dividing them by 60. You'll see you don't get some very nice numbers. But if we did have to do it in kilometres per hour, that would be fine. You just have to use those numbers. As we've got this in kilometres per minute, this is going to be a lot nicer. So the next part of the question says by considering bounds. Now when it says by considering bounds, that means we need to work out the upper and the lower bound, and then we're going to have a look and see how they both round. So we'll start by working out one of them. So if this question here is asking about average speed, so we want to write down our speed, distance, time formula. Now you can obviously write that down, or you can use a formula triangle, whichever you prefer. So with speed, distance, time, when we're working out speed, we want to take the distance divided by the time. Now, as there's a division involved, we need to think about that as well. So when we are working out the upper bound of the speed, we want to get the biggest possible answer, and we get that by doing the upper bound of the distance divided by the lower bound of the time. So we want the biggest number divided by the smallest number. So if we go ahead and work that out, let's see what that would be. So the largest distance is 487.5, and the smallest time is 179.5. And we'll type that in just a moment. For the lower bound, we'd want to do the reverse. So we want the lower bound of the distance, and we want to divide that by the upper bound of the time. And if we put those into that fraction, that would be 486.5 divided by the upper bound, which is 180.5. There we go, 180.5. So let's work these out. So for the first one, pressing my fraction button, or you could just type it as a divide, 487.5 divided by 179.5. There we go, and we get a lot of decimals. So we have 2.715877,437. For the other one, let's see what we get for that. 486.5 divided by 180.5, and that gives us another long decimal. We get 2.695290,859. So we've got both of our answers. We have the upper bound and we have the lower bound. So for this one here, we want to think about how these can both round the same way. So if we look at what we could do, we want to go as far into the decimal as we can. Now I can already see that if I was to chop these both at 2 decimal places, what would I get? Well, for the first one, I'd get 2.72. For the second one, we'd get 2 and that would actually round to 70. So they would not round to the same number. So 2 decimal places is not going to work. Well, let's try 1 decimal place. Well, if I do 1 decimal place, the top number rounds to 2.7 and the bottom number as well rounds to 2.7. So now we have a match. We would just say the answer would be 2.7, and we would need to say exactly why, or the reason why we've rounded it to 2.7. So the reason would be because they both round the same to 1 decimal place. Of course, actually you could use the significant figure reason here as well, which is 2 significant figures. So either one of those would be fine. So I would say 2.7 because they both round to 2.7 to 1 decimal place. Okay, there we go. I'm just going to write they both round to 1 decimal place. The same. Okay, so I'm going to keep it nice and short there as we're just doing an explanation. So 2.7 because they both round to 2.7 to 1 decimal place. Okay, so we could probably add that into 2.7 to 1 decimal place. There we go. So there is our answer for looking at bounds. This obviously involved speed, distance, time as well, and it also involved that concept of by considering bounds, which meant we had to work out both and then check how it rounded at the end. Okay, so for this question we have a quadratic simultaneous equation. So when we are looking at a quadratic simultaneous equation, we have to take a slightly different approach to normal simultaneous equations. Now, some of you may use the substitution method for normal simultaneous equations. I tend to make the same coefficient of y with normal simultaneous equations, so I don't tend to use the substitution method, but for a quadratic simultaneous equation, we're definitely going to want to use that method. So for this particular question here, what we're going to do is we're going to have a look at the non-quadratic equation, and we're going to make it say x or y equals. So for this particular question, our second equation there, if we make that y equals, that would be easier than making it x equals. If I was to make it x equals, I'd end up having fractions involved. So if I can avoid having that, that's probably going to be easier. So to make this y equals, it's as easy as just adding 2x to the other side. So I definitely want to take that approach. So if we do that, we get y is equal to 5 plus 2x. You could also write that as 2x plus 5 if you prefer. It doesn't really matter, but let's just write that down as well. So y is equal to 2x plus 5. Now that I know what y is equal to, I can replace the y squared in the first equation with 2x plus 5. And that's going to mean that top equation only has one letter in it. It's only going to have x's in there. And when it only has x's, that means I'm going to be able to solve it as an equation on its own. So if we go about doing that, I'll put a bracket around the 2x plus 5. I'm just going to put it where that y is. So if we substitute that in, we get x squared plus our new bracket, 2x plus 5, which is also being squared, and that's going to equal 25. And now I just need to expand that, solve it all, and see what we get. Now hopefully you've already spotted that that is going to make a quadratic equation because we're going to have x squareds involved. So for starters, I just need to expand that double bracket and make sure that I'm doing that very carefully. So that's going to be 2 brackets, 2x plus 5 and another 2x plus 5. And if we expand that, let's see what we get. Well, 2x times 2x is 4x squared. 2x times 5 is going to be 10x. We've got another 2x times 5, so another 10x. And then we have 5 times 5, which is going to be 25. So if we simplify that and put it back into our equation, what do we have? Well, we've still got the x squared at the start, but now we're going to add another 4x squared, so we'll be able to combine those as well. We've got the two 10x's, so that's going to be 20x in total. And then we have plus 25, and that equals 25. So we can definitely tidy these up straight away. So that's going to become 5x squared. So we have 5x squared plus 20x. And now I also want to make it equal to 0. So actually I'm going to take away the 25 from both sides. And that's going to be quite interesting for this one, because that means we have no numbers left at the end. But that's absolutely fine. So when I do that and take away 25, it now just equals 0. So now I have a quadratic to solve. Now for this particular one here, this is going to be much nicer to solve, because to solve this, I only have to put this into a single bracket, whereas normally with one of these, I'd have to put it into a double bracket. And obviously on a calculator paper, you can also use the quadratic formula and other methods that you'd prefer to solve a quadratic, but we just need to factorise this, and as I can see, it already factorises. So I can take a factor of 5x out, which would leave me with x plus 4 inside the bracket. So that is equal to 0. Now that leaves me with two x values. And of course, if you use the quadratic formula, you'll be able to get both of these as well. For the 5x on the outside, when 5x is equal to 0, then x must equal 0. And for the brackets, which we should hopefully be nice and happy with, when x plus 4 is equal to 0, x is going to equal negative 4. So as you can see, that's actually easier than had I have had to have done a double bracket, because that would have been harder to factorise. That depends on how you find factorising, but I would say it was probably harder if it was a double bracket. So we have our two x values. So to finish off solving this, I just need to find my y values. Now I've got a lot of options for finding y. I can use any of these equations that we started with, but I would probably go with the y equals 2x plus 5. So if I substitute them into y equals 2x plus 5, if we start with the 0, we get y is equal to 2 times 0, which is 0, add 5. And 0 add 5 is 5. So there's our first one. And if I do the next one, y is going to equal 2 lots of negative 4, which is negative 8, and then add 5. And that's going to equal negative 3. So we have two sets of values. We've got when x is 4, let's go with it when x is 0, when x equals 0, y equals 5. And also, when x equals negative 4, y equals negative 3. And there we go, there's our solutions. So we get two solutions for this one. You're not going to always get two solutions, but you're pretty much always going to get two solutions. If you think about why, it's because we have a circle equation and we have a straight line. So it would look something like that. Okay, it's not going to look exactly like that, but that is just a circle and a straight line. And you can see that on a circle and a straight line, you are going to get two solutions. Okay, there is a scenario where you only get one, and that is if you're given the equation of a tangent where it only touches at one point, and that would only give you one solution. And of course, the line could not cross the circle at all, but then of course we wouldn't be asked to solve it. So there we go, that's how we approach a quadratic simultaneous equation. Okay, so for this question we've got some 3D trigonometry. So you can see here we have a pyramid and it has a triangular base. So it says here that C to D is perpendicular to CA and CB. And we can see that because of these right angles just down there anyway. It also says angles CBD, ADB and DBA, and it's given us those angles which we can see on the diagram. The one on there which is a little strange to see or to visualise is this 60 degrees just here. And that is the angle in the bottom right of this triangle sitting on the front there. So you've just got to be careful with that one because that one does look a little bit strange. You've also got the length B to C, which is 20 centimetres, and it wants us to calculate the size of the angle between the line AD and the plane ABC. Now the plane is the flat base there, so the base ABC, so we want to find the angle between A to D and the base. Now that is the angle on this right angle triangle at the back, just there. So that's going to be what we're looking for. Let's call that angle X. So in order to get that, there is a right angled triangle on the back. And in order to find the angle within that, we'd need either the other angle or we'd need the two other sides. Now, it doesn't look like we're going to be able to get the angle in that triangle unless we at least get two other sides. So we may as well just get the two other sides and then get the angle that we're looking for. So our priority is going to be, how do we get the side D to C and how do we get the side A to D? And if we can get those sides, then we can use SOHCAHTOA to get the angle. So starting on this triangle on the right, this one just here, because we have an angle within that triangle and we have the base length of 20. So if we were to draw this triangle just to the side, and let's just think about how we could get that one. So at the moment we know it's right angled, we've got 20 on the bottom, and we've got the angle of 34. We're trying to find the height. So if we label this up using SOHCAHTOA, we've got the opposite and we've got the adjacent. So we're going to use tan. So writing down our SOHCAHTOA triangle, or the formula if you prefer to use that, we're working out the opposite, so it's going to be a multiplication. So we're going to do tan 34 multiplied by 20, or you could write that as 20 tan 34. So 20 tan 34, we can type that in on our calculator, and that comes out as 13.49 with a few more decimals. So as the question wants it to one decimal place, I want to make sure that I leave all of my working here to at least 4 or 5 decimal places. I'm just going to write down the majority of the number, and then I can at least put in as many as I can. So that comes out as 13.4901703.4. I'm going to label that up on the diagram. I'm not going to write down the full number up here. I'm going to write down 13.49. So that's one of the first lengths that we needed. Now we need to figure out how we're going to get the length A to D. Now to get the length A to D, we're probably going to have to use this triangle on the front. You can see this triangle on the front face here is not right angled. So for this particular triangle, we're going to have to either use the sine or the cosine rule. So if we draw that triangle again to the side, let's just think about what we've got. Now on that triangle, we have that this length is 60. We're trying to find this one, so that's opposite the 60. We have 45 at the top. We've got nothing opposite that, and we've got nothing in the others. So we don't have enough information to use the sine rule yet. But of course, we could get the other angle there because it's just angles in a triangle. So that angle down the bottom, at the moment, 45 and 60 add up to 105. So this would be 75. Now, unfortunately, we still don't have enough information to use the sine rule or the cosine rule, but we might be able to get one of the other lengths. And we can do that by, again, looking at this triangle just on the right here. We already have 2 of the lengths for that triangle. So if we go back to our first triangle, how do we work out this length just here? Well, we can actually do that by using Pythagoras, because we've got the height and we've got the base. So if I apply Pythagoras to that, we would do, and let's just write down part of the number, 13.49 squared. And we're going to find the longest side, so we're going to add 20 squared, and then we're going to square root our answer. So I'm going to write that all in one go. I'm going to assume if you are doing 3D trigonometry that you're also pretty clued up with Pythagoras. So I'm not going to go into too much depth explaining Pythagoras there. But if we type that in and square root our answer, we get the answer 24.124, and there's a lot more decimals there, 35897. Okay, so quite a lot of decimals. So there we go. We have now another side on our front triangle, and that is opposite the 75. So if we write that in just here, 24.1243587. It can get a bit annoying during the questions to keep writing down all the decimals, but you don't want to lose a mark at the end because you've rounded your answers too early. So now looking at this triangle, I can work out the length A to D. Once we've got that, we're going to be able to just about finish our question, but obviously there's a lot of steps in this question. So I have a pair of opposites here and here, and a pair of opposites with one that I'm looking for just there. So this question is going to involve the sine rule. So I want to label up the sides. So let's just call this little a and big A, little b and big B. And remember, when you're using the sine rule, you only really need to use A and B, and you can put the letters in any order that you want, as long as you obviously put them on the pieces that you're looking for. So for this one here, let's put that into the sine rule. So we've got A over sine 60, and that's going to equal B, which is 24.124, 4. I'm not going to write down all decimals there. I will do when I type it into the calculator, and that's going to be over sine 75. So for now, in order to rearrange this to get the value of a, I need to multiply both sides by sine 60. So when I do that, you can either work out the fraction on the right and then times it by sine 60, or I can type it all in one go. I'm going to type it all in one go, so I'm going to write 24.124, again using the full number that's still on my calculator, multiplied by sine 60. I'm going to divide that all by the sine 75. So if I type that into my calculator, I already have that 24.124, so I'm going to type answer sine 60 all over sine 75. Press equals, and I get my final length there for A. Now that comes out as 21.629, and then we have 30853. So 30853. And also bear in mind, I haven't rounded a single answer here. So if you're rounding your answers at all, yours might come out slightly differently. So now we've got that length up there. Let's label that on the main diagram. 21.629 and then 30853. There we go. So how are we now going to finish off this question? Now, as you can see, we've already done a lot of working out, but I've got the lengths that I need to finish the question. So I'm going to have to get rid of some of the working out here because we've got a lot on the screen. So I'm just going to finish writing off that number there, 7034, because I am going to use the full number. But we're going to need to get rid of some of this working. So to finish this off, we are now looking for the angle between AD and the base. And to get that, all we need to do is use SOHCAHTOA, obviously looking for an angle. So we're going to use the inverse of sin, cos or tan, and then we get the angle with that. So the triangle on the side, which we can visualize just like this, it has a hypotenuse length of 21.629. It's got a height of 13.490, and we are working out this angle. So using SOHCAHTOA for this part, we've got the opposite, and we've got the hypotenuse. So O and H is in our sine triangle. So SOH. And when we're looking for the angle, we're going to do the inverse of sine. So I'm going to do sine minus 1. When you cross off the S, it's O over H. So we're going to do 13.490 divided by 21.629. Right, so typing that into your calculator to get that, shift sign, press the fraction button, 13.490, and again, I'm going to put the whole decimal in, so 17034 over 21.629, 30853. There we go. Close the bracket, press equals, and I get 38, and let's write the answer down here, 38.586,73479. Don't need to write down all the decimals there because it does say it wants my answer to one decimal place, so I'll chop it after the 5, and my final answer will be 38.6. It was asking for an angle, so that's degrees. So my final answer is 38.6 degrees, and that's the final answer for that question. Now, as you can tell, that is obviously a lot of work. Particularly this question, it's a very difficult version of 3D trigonometry. We had to find the two lengths on the right side. That involved using SOHCAHTOA and Pythagoras. We then had finding a length on the front there using the sine rule, and then putting that all together to find the angle using the inverse of sine in the final step. So a lot of marks for a question like this, a lot of working out, and a lot of knowledge of trigonometry, and obviously further trigonometry where you could have the sine or potentially the cosine rule in one of these questions. Okay, so for this question we're looking at a histogram. So it says here the table gives information about the speed in kilometers per hour of 81 cars. On the grid, draw a histogram for the information. And you can see on this particular grid we've not been given any scales on the axes, so we're going to have to draw it ourselves. Now on the left of a histogram we're going to plot the frequency density, which we're going to work out from the table. And on the bottom we're going to plot the information that we're looking at, which in this case is the speed. So for this, we need to find the frequency density. So to work out the frequency density, you take the frequency and you divide it by what we call the class width. And the class width is the distance between the class. So from 90 to 100, that class width will be 10. Now what you could do is you could write down the class widths in the middle if you prefer, or you could just do it as you go along. I'm going to write CW for class width. So from 90 to 100, that width is 10. From 100 to 105, that's 5. 105 to 110 is 5 again. Then we've got 10, and then we've got 20. So if I take the frequency and divide by the class width, we can do that on the calculator. 13 divided by 10, I'm going to label this up here for frequency density. That comes out as 1.3. For the next one, 16 divided by 5, that comes out as 3.2. 18 divided by 5 comes out as 3.6. 22 divided by 10 is 2.2. And 12 divided by 20 comes out as 0.6. So now we have our frequency densities, we can see how big the histogram needs to be. Our largest frequency density there is 3.6. So if we do this going up to 4, so at the bottom we've got 0, and then every 10 squares, you can normally see there's a slightly thicker line, you just have to look very carefully for that. Make sure you get it accurate. It looks like that scale is going to work. So 1, 2, 3, 4, and we'll go up to 5, but there we go, we didn't need to go past 4. So moving on from this, how are we now going to draw the rest? Well, we need to plot the speed down the bottom. So if we plot the speed down the bottom, we're going to have to go from 90 up to 140. So if we start on 90, and we'll see if we can go up every 10. So that would be 100, 110, 120, 130, 140, and that's going to perfectly fit. So 100, 110, 120, 130, 140. And obviously make sure that you do these in pencil, because then if you find that your scale is too small or too big, you can always rub it out and start again. So let's obviously plot these on here. So we want to draw this in, so from 90 to 100, that has a height of 1.3. So I want to go 3 squares past the 1, and obviously do this nice and neatly with a ruler and a pencil. And there's our first bar. Our next bar is connected to that, and that goes up to 3.2. So that goes from only 100 to 105, so I want to draw that quite carefully. I'm going to go up from here to start with, 3.2, and then down with the 105. Obviously you can make this look a lot neater than mine, because you can do this with a ruler and a pencil. For the next one, that has a height of 3.6, that's our largest bar, so we want to go just a little bit above the halfway between 3 and 4, go across nice and neat across that line, and then down to the 110. The next one has a width of 10, that only goes up to 2.2, so I can follow on from the edge of the bar. There we go, and that has a width of 10. The next one has a width of 20, and that only has a height of 0.6, so it's just above the halfway point. And there we go, and there is our histogram drawn. Now you don't have to shade in the histogram or colour it in or do any sort of key, you just have to make sure it's drawn nice and neat, you can see those lines nice and clearly. Also, do write the full word frequency density here. I've just written FD, just so there's not too much writing on the screen. So there's your histogram drawn. Now this particular histogram is also asking us to find an average from the histogram. It says find an estimate for the median. Now when you're finding an estimate for the median, there's just a couple of steps that you need to do. So what I'm going to do is I'm just going to get rid of this working out that we've done so far for the histogram. Obviously you're going to have a lot of space on your page, but we'll just get rid of this and we're just going to think about finding an estimate for the median. Now we are just finding an estimate. So to start with, I'm just going to halve the 81 cars. That's going to give me an estimate of where the middle is. So if I divide that by 2, we get 40.5. So I'm going to look and see where the 40.5th car is. So if I go down my table, we've got 13 at this point. Adding 16 will get me to 29. And then when I add 18, that's going to go past 40.5. So how far do I have to go into this class to get to the 40.5th? Well, to get to 40.5 from 29, you could obviously just do on your calculator 40.5 take away 29, and that gives me 11.5. So to get to the median car, the one in the middle, I'm going to go a fraction into that bar. Now specifically, the fraction that I'm going to go is 11.5 out of 18. So that's the fraction of the bar that I'm going to look at. So if we think about this as a bar length of 5, because the class width goes from 105 to 110, the fraction of the bar would be 11.5 over 18 as a fraction of 5. Now we can work that out by just timesing it by 5. So if we type that in on the calculator, 11.5 out of 18 multiplied by 5, which is just finding that fraction of 5, we get the answer, it's not a nice number, 3.194, and the 4 is recurring. So that's how far into that class the median lies. Now that class starts at 105. So if we go 3.194 on top of the 105, or in other words, 105 plus this additional 3.194, that would leave us with, and of course that's not too difficult to add, but we can add it on the calculator, and that leaves us with 108.194 recurring. And that would be our final answer for the median. It would probably be fair for you to round these, but it doesn't say to give your answer rounded to any amount, so it would be absolutely fine for you to leave your answer as 108.194 recurring and have that as the median. Now there are obviously some slightly different rounding ways that you could do this question, but of course it only says to find an estimate, so it was fine for us to just halve 81, and it is fine for us just to leave our answer as we've done it there. But the important part for finding the median is that you figure out what fraction that you have to go into that particular bar. In this case it lay within the 105 to 110. We had to go 11.5 into that. That was 11.5 out of the 18 that were in the frequency for that bar, and the bar's width was 5, so we found out that fraction of 5. Obviously if it was a nicer fraction, it's easier to say, like if it was 2/18 or 1/9 that would be, then we'd go 1/9 into the bar. But 11.5/18 just sounds a little bit strange, so it does make this sort of fraction of 5 seem a little bit more complicated than it actually is. But there we go, there is our question on histograms. Okay, so well done for making it to the end of the video. As you already know, we've gone through our 5 questions, looking at iteration, bounds, quadratic simultaneous equations, 3D trigonometry and averages from a histogram. Now, as I showed you at the start, there are tons of different questions and topic videos that you can actually have a look at in regards to these 5 topics. So do check out all of those in the description, particularly any of these that you were struggling with. I hope you found that useful and helpful. If you did, don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you for the next one.